Well, okay. So the first derivative gives us information about the graph concerning the slope. I'm finding the equations of tangent lines, slopes of tangent lines, but also the slope at a particular point on the graph. In our next unit, we will figure out what the second derivative has to do with the shape of the graph. But in the meantime, hey, if I can find the first derivative, I want to also be able to find the second derivative. There's going to be some uses for that particular thing coming your way soon. So I have on example 9, y squared is equal to x. We want to find the second derivative of that equation. I would say function, but it's not a function, right? We've already talked about this. This is that sideways parabola. And as a matter of fact, I do believe that we found the derivative of y with respect to x as, let's see, that would be 2y. Is it 1 over 2y? I think that's what it was. Okay. All right, now, in order to find the second derivative, you must first implicitly find the, let me say, did I say that right? In order to find the second derivative, you must first implicitly find the first derivative and then find the second derivative from there. All right, that's what we're about to do. So to find the derivative of this now, I'll have to do it implicitly because I have y's over here on this side. And by y's, I mean 2 of them. See, 2 y's. Now, I've got a couple of options. I can use the quotient rule on this thing, or I can be super clever about it and then just rewrite that as 1/2 y to the negative 1 power, right? And not have to use the quotient rule on it. Now let's take its derivative implicitly. d2y over dx2 is equal to, leapfrog that power down, so negative 1/2 y to the subtract 1, negative 2. And then since we took the derivative of y, which is understood to be at least one function of x, we're going to multiply it times dy dx. Boom. All right. Here's the thing about finding the second derivative when we're talking about implicit differentiation. It always calls back to the first derivative. And one of the things that will be absolutely necessary is to take this and get rid of it and substitute in the first derivative back into its place. So we're going to do that here in a jiffy, and this is after I fix this a little bit. I'm going to get rid of that negative exponent. So that negative exponent is negative 1 over 2y squared, and then we're going to multiply that times dy dx. Again, I need to absolutely substitute this, so I'm going to make a big deal about this. I'm actually going to color this in. And then, you know what? I'm going to make a little box around this one too. You know what? There we go. Okay, so yes, we got to do some back substitution here. And let's go ahead and write that then. So I've got negative 1 over, whoa. There's not enough room here. I'm just going to bring it down here. Negative 1 over 2y squared times 1 over 2y. Okay, so then let's just multiply. It's just 2 fractions. It's negative 1 over 4y to the third. There we go. So here is the second derivative of this implicit equation. Okay, so let's say this was a multiple choice test question. I look at my answer choices, and this one is not there. I know I've done all of the math correctly, but the reason why it's not there is because sometimes they do something clever, and that is y squared is equal to x. So someplace where I have a y squared, I could take it out and I can substitute x back in its place. And you know what? I think that happens. I could have done it right here. So for example, let's maybe switch colors here to, how about this nice green color? Boop. I could have made this negative 1 over 2x because y squared is equal to x, and then multiply it times 2y. Whoops, 1 over 2y. To get negative 1 over 4xy. So here is an alternate form of the second derivative. All right, so just let me recap here. When you're going to find the second derivative implicitly, you are often going to have to use some substitution. The first substitution is going to be substituting the first derivative in for dy dx. Whenever you take the derivative of the y, it's going to have a dy dx inside of the second derivative. You got to get rid of it, substitute in whatever equation that you came up with for your first derivative. And then, secondly, you are looking for some opportunities to replace the original equation into that second derivative. That doesn't always happen, but just understand that if this is on a multiple choice question and your answer doesn't match, that's one of the things that you could possibly do in order to simplify your answer.